Good morning, students. Welcome to the class of chemistry, 8th standard. Today, we are going to start with a new lesson that is elements, compounds, and mixture. Now, we have learned in our lower classes that matter can be classified into solids, liquids, and gases on the basis of their physical properties. At the same time, matter can be divided into elements, compounds, and mixture on the basis of their chemical properties. Now, all the substance which we see around us is matter because we have learned that matter is something which occupies space, has certain mass, and can be perceived by our physical senses. That means we can feel them. We have already learned in the previous classes that matter can be classified into pure substance and mixture. Now, the term pure, which is used in our day to day life, describes the substance should not have any contamination or should not be polluted. For example, if I say pure water, it means it should not have suspended impurities or germs in it. Pure milk means no one has added any water to it, or like these days, even detergent, urea, etc., are being added to prepare synthetic milk. Now, according to a scientist, pure substance is defined as a material which is made up of only one kind of atom or molecule and has a definite composition and property. For example, if I say hydrogen gas, that means if I fill a gas in the cylinder, that should contain only H2, hydrogen, and no other gases should be present in the container. You can see in the example given in your book, iron, gold, sulfur, tap water, sugar, etc. are the pure substance, which has fixed melting point and fixed boiling point. Now, students, please remember this. In chemistry, we consider the boiling point and melting point as a property of purity of substance. Like if your water is pure, water will freeze at 0 degrees Celsius. That means water will start getting converted into ice at 0 degrees Celsius and water will boil at 100 degrees Celsius. If water is boiling at 100 degrees Celsius, that means the water is pure. It does not contain any impurities. Now, pure substances are further classified into elements and compounds. Now, matter is not always pure. Some substances get randomly mixed, so no longer the purity is maintained, and such impure substances are known as mixtures. In this chapter, we are going to do the classification of mixture as homogeneous mixture and heterogeneous mixture. In the later part, we are going to classify elements as metals, non-metals, metalloids, noble gases. Today, we are specifically going to focus on elements and compounds. So, what are elements? Element, a pure substance made up of same or single type of atom, is called an element. For example, if I use a term carbon, I'll write only C there. For hydrogen, I'll write H2. For nitrogen, I'll write N2. So, what are these? These are elements. About 118 elements are known to us. In your successive years, I'll be teaching about the periodic table where I'll teach you that we are aware of 118 elements today. Now, from the examples which I've given you, if you can see, there are some elements which are singular and some elements occur in the diatomic form because these elements cannot exist in a singular form. So, here in your textbook, if you see, it is given some other elements such as oxygen is stable only when it combines with either another oxygen to form a molecule of oxygen or some other element to form a molecule that is like oxygen combines with hydrogen to form water. It combines with magnesium metal to form magnesium oxide. Therefore, these compounds, like water and magnesium, they are known as compounds because when two atoms of different kind combine in a fixed ratio, they are called as compound. Like here see in their book, they have given you an example. Oxygen reacts with sodium metal to form sodium oxide. In short, you can remember In the word form of this equation, oxygen plus metal will give you metallic oxide. You can use any metal, you will get the corresponding oxide. Among elements, also some of them like radium, radon, krypton, they emit radiation, and these elements which emit radiations are called as radioactive elements. Out of 180 elements, 36 elements are radioactive in nature. Some elements have low reactivity, like gold, silver, platinum, etc. And the number of atoms present in a molecule, it's called its atomicity. Now, when I say atomicity, that means it indicates the number of atoms present in a molecule. If I say hydrogen, it is H2. That means two atoms are present. Therefore, atomicity of hydrogen is 2. If I say phosphorus, phosphorus is P4. Therefore, its atomicity is 4. If I say water, water formula is H2O. It contains two atoms of hydrogen and one atom of oxygen. Therefore, its atomicity is 3. If I say sodium chloride, NaCl, it has two atoms, one atom of sodium and one atom of chlorine. Therefore, its atomicity is 2. In simpler words, the number of atoms present in a molecule, it's called its atomicity. If I say carbon, its atomicity is 1 because it contains only one atom of carbon. Sodium, its atomicity is again 1 because it contains only one atom of sodium. Now, in the later half of this chapter, I'm going to teach you that elements are classified or further divided into metals, non-metals, noble gases, and metalloids. Regarding reactivity, you have done a series in the 7th standard that is called as reactivity series. That was arrangement of elements in the decreasing order of their reactivity. If you remember, potassium was at the top and gold was at the bottom. That means potassium is the most reactive metal, whereas gold is the least reactive metal. Now, what is compound? A pure substance is made up of two or more elements chemically combined in a fixed proportion under fixed condition is called a compound. For example, let's take a common example of water. Now, in case of water, the formula is H2O. That means two atoms of hydrogen combines with one atom of oxygen to form water molecule. Now, if you take water from the lake, pond, river, everywhere, if water is in the pure form, it will contain only two atoms of hydrogen and one atom of oxygen. The ratio would be 1 is to 8. From where I got this ratio 1 is to 8? Atomic mass number of hydrogen is 1, and as we have two atoms of hydrogen, it will be 2. Atomic mass number of oxygen is 16, so 2 is to 16. If we make it in a simpler form or convert it in a simpler form, the ratio comes to be 1 is to 8. So we can clearly make a statement here that water combines in the ratio of 1 is to 8 by mass to form a compound. And this ratio is always fixed. It will not change. Therefore, combination of hydrogen and oxygen is called a compound. Other examples of compounds are like calcium carbonate. The formula is CaCO3. Here, calcium combines with carbon and oxygen in a fixed ratio. Sugar, molecular formula being C6H12O6. Common salt, NaCl, sodium chloride. So these are the examples of compound. Now, compounds can be separated into their constituents only by chemical method. Like water can be separated into hydrogen and oxygen by passing electric current through it. And the process is known as electrolysis. Please remember this word, electrolysis. This will be used by you in 9th standard as well as in 10th standard. What is electrolysis? When you separate the constituents of a compound into its ion or into its constituents, it is called as electrolysis by the passage of electric current. Here you can see the reaction. 2s2o on passing electric current gives you two hydrogen atom and an oxygen molecule. So properties of compound are different from the properties of the constituent. How can we say this? Like as you can see, water is formed due to the combination of hydrogen and oxygen. Now hydrogen is a gas. At the same time, oxygen is also a gas, but water is a liquid. There is a change of state. First indication, that's just a chemical change. Second thing is oxygen is a supporter of combustion, whereas water is used to extinguish fire. So the properties are different. So here we can conclude that properties of a compound are different from the property of their constituent. Now let's look at the other example. Carbon is a combustible substance. Oxygen supports combustion, but the compound carbon dioxide produced from them is used to extinguish fire. You can see the reaction also. C plus O2 gives you carbon dioxide. Carbon plus oxygen gives you carbon dioxide. Now, oxygen is a supporter of combustion, whereas we use carbon dioxide in the fire extinguisher. The fire extinguisher cylinders which are placed in the schools as well as your cars contains carbon dioxide. Now, this is used as a fire extinguisher because it extinguishes fire. Now, sodium burns in atmosphere easily, where chlorine is a suffocating gas. But the compound which is found is a combination of sodium and chlorine is sodium chloride, and which is used as a common salt. It's an edible salt. And as the properties are changed, so the nature of the compound also, or nature of the combining elements or the constituents also changes. Now, during the formation of a compound, energy is either absorbed or released. Now, we have done this term. When energy is absorbed in the form of heat, it is called as endothermic reaction. And when energy is released in the form of heat, it is called as exothermic reaction. And just to recollect, how can we identify whether the reaction is exothermic or endothermic? If heat is written on the reactant side, what I said, if heat is written on the reactant side, like here, it is endothermic because we require heat for the reaction to take place. And if heat is written on the product side, that means heat is liberated during the reaction and it is exothermic. Here, the example of endothermic and exothermic reaction are given as N2 plus O2, that is nitrogen plus oxygen, gives you nitrogen monoxide. This is a poisonous gas. This is an atmospheric pollutant or air pollutant. At the same time, you can see nitrogen combines with hydrogen to form ammonia. That is N2 plus 3H2 gives you 2NH3 ammonia and lot of heat is liberated. Here, the first example is of endothermic reaction, and the second example is of exothermic reaction. These compounds are homogeneous. Why I say homogeneous? What do you mean by the term homogeneous? When we have same constituent throughout the mixture, it is called as homogeneous substance. Now, what is a mixture? Please remember, in compounds, the combining atoms combine in a fixed ratio by weight under fixed condition. A substance made up of two or more than two substances, that is, elements or compound, mixed in any proportion and under any condition, it is called as a mixture. Like air is a mixture because air contains different gases in different proportion at different places. In cities, the content of carbon dioxide may be more in the air. In rural areas, where there is less pollution, the amount of carbon dioxide may be less. So you have in your textbook also the example given is of the air. You can see, for example, gases present in air vary in their percentage from place to place or season wise. That is, carbon dioxide in air is more in industrial areas, water vapor are more during rainy seasons and the coastal areas. Compound and mixture can be separated by simple physical methods such as filtration, sublimation, distillation, etc. In mixture, properties of its components are retained. For example, iron is magnetic in nature. If iron is present in the mixture of iron and sulfur, it still shows the magnetic properties of iron. Yellow color of sulfur is visible in the mixture of iron and sulfur. Sweet taste of sugar is retained in the mixture of milk and sugar. Like if you are mixing milk and sugar, or if you are dissolving uh, salt in water, still when you are drinking that salty water, you can still sense the taste of salt. Now let us understand. Let's take one example at home as you are doing your learning at home. Uh, what actually mixture is? Take three half glass of water. In first glass, add half teaspoon of salt. In second glass, add